Thank you all for coming in person. I really appreciate it. This has been my first talk that I get to give live in person, so really exciting to see faces again. So my talk today is going to be around GitOps 101. And about 5 years ago, I was here and I gave my first talk at All Things Open, and it was actually a Git 101. So this is sort of an evolution for me as we start to look at not just how we leverage Git on a day-to-day basis, but how do we actually use it to provide some efficiencies around how we do operations today inside of some of the world's largest companies who I've given this talk to before. So a little bit about me. I've got over 20 years of experience both on the development and the IT side. So I'm one of those weird people who actually enjoys both. I've actually been at the state capitol building. I've actually pulled fiber inside the building. That wasn't necessarily one of my favorite jobs that I did, but I did learn a lot about routing and switches and hubs and networking and things along those lines. I started in OSS back in 2000. I was working for a startup at NC State. And I was doing a lot of work with the JBoss community at the time. We were doing a lot of work around J2EE. Yes, I still say J2EE, not just JEE. And along those lines, what we were doing is the product that I was working on, we were doing a lot of work with making it easier for people to be able to deploy applications, distributed applications. Different open source companies I've worked at, Red Hat Alfresco, Armory, and now I'm currently with Gitlab. Different proprietary companies that I've worked for. TogetherSoft was that startup here. Also worked for CompuWare and GitHub. I started as a teacher here at Wake County. So if anybody here ever went to school at Athens Drive High School, I taught at Athens Drive. I was also an adjunct professor at NC State. So any NC State students in here, welcome, welcome. I currently live in Mooresville with my wife and 2 daughters. This is Mooresville, not Morrisville. So a lot of people get those two confused. So just north of Charlotte. So understanding GitOps. So we've got to go back in time. And when we go back in time, I remember days when we used to have physical data centers. And whenever you wanted to make an update to anything on any of the servers, you had to have a special badge. And that badge allowed you to be able to get into the data center, get to the server, and you used to have these little pull-out keyboards, or you had a little connection that you would connect into serial into your servers. And when you would do that, that would get you the ability to sort of SSH into the machine or RDP into the machine. And that's how we would make our changes. And we would have to make those changes one by one. You would go from server to server to server. When we started getting to the point that I started automating some of this, I was working for a company where I was a technical trainer, and we used a program. I can't believe I actually found it online when I was researching this presentation. It's called Semantic Ghost. So anybody here ever use? Yeah, so they got some Semantic Ghost users. So way back in, some people not liking Semantic Ghost. So what Semantic Ghost did is it took basically a picture of your hard drive, and then you could store it out on the network, and then you could use a diskette. Yes, I said that word today. I said a diskette. You would put the diskette and boot directly onto the network and actually clone that disk image down onto the hard drive that is on your machine. A lot of the technologies that we use today, like Kanji and different MDM technologies that exist for our Macs, that's actually where a lot of that technology started, was with products and people who have left from that Semantic Ghost days. Today, the data center has evolved. And what I mean by that is before, when we used to have to serial into the different servers and into the routers and TFTP and all of these other things, the servers are now API enabled. And that scares a lot of people in operations. API enabled. Oh, hold on, wait, you mean my developers can now program my stuff? I'm not saying that we're going to let anybody access those APIs, but what we're able to do is we're allowing abilities to shift the configurations of the devices in real time. So you can think about things whenever there's a denial of service attack. How quickly do you want to reroute your traffic internally so you're not causing a burden of some users? You want to reroute some traffic to allow your applications to maintain up while you go ahead and set up your honeypots and other things to reroute traffic in another direction. You can't wait 30 minutes, an hour, 2 hours for that configuration to take effect. You want that to take effect immediately. The other things that we have now is we've got a lot of tools that exist that give us a command line access to those particular devices. Back in 2011, I was working as a chief cloud architect, and one of the things that we wanted to be able to do is when we deployed our applications from performance into stage and then stage into production, we would literally have just 2 different IP addresses. And what we wanted to be able to do is when we felt like staging had baked long enough, all we wanted to do was just switch IP addresses. So that way what we could do is we could have our external load balancers and our internal load balancers see that new traffic and then just route to a new version of the application. If anything went wrong and we started seeing really bad things occur, all we had to do is go back in and switch them back. So this whole idea of redeploying applications over and over and over again for those people that are delivering applications at scale, you can imagine delivering 50,000 images, VM images. If you had to redo that on the fly for a new version of an application, it's going to take a while. If all I have to do is flip a virtual IP address, that happens instantaneously. Now, a lot of those things that we've done around APIs and CLIs, a whole new breed of application language has emerged from that. So what we've been able to do is we're able to now take advantage of infrastructure as code. So companies now exist like Puppet and Chef and HashiCorp with Terraform. You've got Ansible that came out of a group from Red Hat that then ended up coming back to Red Hat. So these infrastructure as code providers are really leveraging those APIs and those CLIs to their advantage to allow us to streamline the deployment of infrastructure at the same time that we're actually trying to deploy our applications. So we're able to do all of this at one fair swoop. The other thing that we have now is a lot of people who are creating platforms on top of this concept. So those platforms as a service, your developers are now able to consume services rather than consuming infrastructure. So I don't need to say, oh, I need a new Postgres database. And when I say I need a Postgres database, I need to go and provision a VM, install all the middleware, make sure the kernel's tuned the right way, all of these. All I do is I just give you access to a new database endpoint. And everything else behind the scenes is managed automatically through the operations team. The developer is unaware that any new infrastructure has ever even been provisioned. And there's something that is starting to emerge that a lot of people, as they start to move towards Kubernetes, is Kubernetes isn't just a deployment target. We're starting to see a lot of companies as you're able to take advantage of things like config maps and secrets and state management and etcd, that we're actually seeing people leverage it as a control plane. So now what I can do is I can create my configuration, not just for my deployment of my containers, but for my infrastructure, and I can use the capabilities of Kubernetes, because really Kubernetes is nothing more than a set of APIs around all of those different resource definitions. And if I can create those resource definitions as infrastructure resources, why not use it to be able to control those things? So companies, I know there's a company here this week called Crossplane. There's another company called Seaplane. There's another one out of Seattle called Crossplane. So there's a lot of different ways of companies that are starting to merge in this space that are trying to disrupt the infrastructure as code space. Now, back in 2005, I worked for a small company here in Raleigh called Red Hat. And when I worked at Red Hat, what we did is we had a need to be able to have our small little application that we wanted to run in the data center. We had a little startup team called the Red Hat Exchange, RHX. And when we were building it, my manager had told me and said, hey, look, you need to go work with the database team because we're going to need some servers, we're going to need a database. And so I go ahead and I walk on over, and it's the Oracle team. And I'm like, wait a second, I just came to Red Hat. Why all of a sudden now I'm using Oracle? And they said, yeah, we use Oracle internally. And I said, okay, so I want to run MySQL. And they said, we're sorry, we don't support MySQL. And I was like, well, what if my team supported MySQL? And then the whole big debate went on, and I'm like, this is not a quote unquote what you would traditionally see in Red Hat as a production application, so give us an exception. And they came back and told us, they said, it would be fine for you to use MySQL, but you have to purchase the servers that are the same size that we use for Oracle. I'm sitting there going, okay, no big deal, that's fine. This is back in 2005. I needed an 8-way box with 64 gig of RAM, and each server was over $50,000. So I'm sitting there going, I'm telling my boss, I'm like, look, we gotta buy this box. And he was like, okay. And I said, oh, and by the way, we need HA. So we're gonna need 2 of these boxes. So we ended up buying 2 of the boxes, but we were running a small little MySQL server on this server. So the first thing that we did is we had this great technology that we were using at the time called Zen. So what we did is we ran Zen on top of these boxes, and we just sliced and diced those things. They became our dev, QA, stage, prod. They became everything, and we ran our database. Everything was running as a VM on these huge boxes. And one of the efficiencies that we saw out of that is we started using Puppet when it was still Puppet Labs out of Nashville. And another team that was internal to Red Hat was building something called Cobbler and Funk, which ended up becoming Ansible down the road. And we used something, we were building our application in Ruby on Rails, so we used something called Capistrano. So we were able to think about our 2 boxes that we had in 3 different things. We had infrastructure, middleware, and application. And so from an infrastructure perspective, we had scripts that would run on the bare metal boxes with the operating system with Red Hat running under the hood. And that was managing all of the things for IP addresses. It's how we connected into the data center. And then all of the VMs all connected then through that underlying Red Hat layer. And then we installed all of the middleware into those VMs. So we could re-provision those VMs every time we had an update to the application. Instead of just having one big bare metal box and reinstalling into that bare metal box, we just redeployed a brand new scratch VM and then started from the ground up to go ahead and install everything that we needed. So we always had a clean install. Yes, this was back in 2005 when we were doing this. As we started creating a lot of these different tools inside of Red Hat, we started having code that started looking something like this. Now, this is actually Terraform code behind me, and I know Terraform did not exist in 2005, but imagine this looking like Puppet code. So when you look at this, it is how I would define an EC2 image inside of AWS. And all I need to do is provide it with some metadata. And then I have a CLI behind the scenes that executes against this particular file, and it will go and perform the actions based on this metadata. So when we think about doing this, there's a lot of operations people that start to get a little concerned because, you know what, this looks a lot like source code. And a lot of things that we don't have built up inside of our organizations is a best practice for how do I treat my operations, my platform engineering, my SREs, how do I treat them like I do my application developers? Well, to be able to accomplish that, because this looks a lot like source code, guess what? We actually have best practices for how we manage source code. We actually go through a requirements definition. So we've got user stories, we've got things with testing, we've got all of these things that we set up before code can ever go live. So we can now inherit those best practices And we can give those to our operations teams to allow them to define our infrastructure, our middleware, our applications in the exact same type of rigor. We can inherit our agile best practices. No longer do I have to wait 6 months for somebody to procure me hardware, have it go ahead and get racked, have it go ahead and get connected to my network, and then I can finally go ahead and start deploying my application to it. I can start to consume these resources on the fly today, whether that's through an internal data center or through the cloud. So now we have to think about, well, where is our source code stored? Well, we need to find a location for this. So today, a lot of the places where this code's going to be stored is it's going to be stored in a Git repository somewhere. And so we're going to have our Terraform, Ansible, Puppet. That code's going to live in the exact same place where my Spring, Java, React, that code's all going to live together. Sometimes that code can actually be in the same repository where it exists. And there's all kinds of different ways, combinations, permutations about ways that we can leverage best practices across our entire organization, because all of the things that we get by using tools like GitHub, Bitbucket, Gitlab, and providing transparency and collaboration. Imagine you want to go make a change as an operations person to change the configuration for the default EC2 image for your organization to go from a 4 CPU box to an 8 CPU box VM every time it happens. Well, wouldn't you like to know that before you start making that change across the entire organization, that you've got financial buy-in, that you've got developer buy-in, that you've got your security buy-in, that this actually makes sense? So now what I've done is, because I've opened up this collaborative nature of being able to share how we're going to define all of our infrastructure, I get all of these advantages. I get a developer workflow that's already been established through a pull request process or a merge request. Please do not go in and say, oh, I'm part of the operations team, I'm just going to commit straight to main, or I'll just commit straight to master. That totally goes against everything else that the development teams have already established. So when we go through a pull request, merge request process, which I'm actually going to demonstrate, you'll see how you can go ahead and provide input from other people. The other thing that we get is we get a segregation of duties. So one of the things that you're able to do is there's this notion in Git called a branch. And that branch is a little sandbox by which you're going to make your changes in. And once you've made those changes and they've been approved, I can merge them into the main line where every other piece of code is being stored. I also get the ability to have increased security and traceability. People are like, well, hold on, wait. You want me to share our definitions for how we create all of our infrastructure for my entire Fortune 50 company where everybody else can read it? How many people here have ever used SSH? Used SSH? Okay. Is SSH proprietary? Nope. SSH is an open source project, completely transparent. How is it that if something like SSH is completely open and transparent, why is it every single one of you that have an SSH server running is not being hacked at this moment? Because like Linus Torvalds says, when everything is transparent, all bugs are shallow. So when something actually is not right, somebody else inside your organization is going to call you out. They're going to tell you, this is not a best practice. This is not the way that we manage this. Here's a better way of how we can fix this. So being able to provide that transparency inside your organization will allow us to have traceability from beginning to end and increase the security of everything that we're provisioning internally. The collaboration and reuse, this is a really soft buzzword that a lot of people in the community will talk about developer experience. And a lot of people don't give a lot of weight, especially executives. They're like, how do I measure that? How do I measure developer experience? Well, the way you do that is through attrition. How quickly do people leave your organization? If you've got a merry-go-round of people who come in and out of your organization, your developer experience is lacking. If you're able to bring people in and they get excited about coming to work and you enable a remote work culture and they can go ahead and contribute code from anywhere that they are, anywhere in the world, man, what a great experience that I get. I can do my job when I need to do it without being forced to just work from 9 to 5. And then also being able to create reuse. The reuse is critical for auditing and compliance. People don't realize that auditing and compliance is not hard to achieve. Auditing and compliance is all about workflow. It's about process. And once you define a process for how you create, how you change, and how you deploy, once you have that established, you pass your audit. Once I'm able to go ahead and document that process, the only time I need to go back to my auditors is when that process changes. If you change 25 files, as long as I follow that change management process, I'm in compliance. I am good. So that developer workflow that we've already talked about establishing, if I inherit that for my change management process, I immediately am going to get compliance out of the box. It's a well-defined workflow that already passes compliance at some of the highest security in our national government, federal government. So let's go ahead and let's look at what this is going to look like. So let's cross our fingers that the screen stays shared. All right. This is the first time I've ever done this. I think I've gotten old through the pandemic that now all of a sudden I'm going to talk and try to use my reading glasses at the same time. Thanks. So this is probably a little hard to read. A bit of an eye chart. Okay, so what I've done here is I've got some Terraform code. And when we talk about creating repositories where our data, where our infrastructure as code is going to live, there's a best practice in the open source community. And that's about having some common files that we want to actually tell people about this particular repository. So down here, down at the bottom, I have a README. So this is for anybody else. So this is sometimes scary for somebody. What I'm going to do is I'm going to share with you not only what I've created, I'm also going to share with you how to use it, and I'm going to show you how to automate it. Wait, isn't that my job? Like, I'm basically telling everybody else inside the company how to do my job. That's scary. But what this should alleviate you from is having, every time somebody comes along and says, oh, Susan, can you walk me through that process again for how do I create an EC2 image on AWS? Yeah, there's the docs, there's the repository. Just go ahead, run through that, you're good. You alleviate yourself from having to be the person who is the owner of the change and being the provider of the change. So now the ownership, going back to compliance and auditing, you can be the reviewer of a change now instead of being the implementer of change. SOX compliance 101, person who makes a change cannot be the person to approve the change, cannot be the person who deploys the change. So I got 3 people that have to be able to approve this thing. So if I'm the person who owns it, that means I've got to find 2 other people around me that can approve it. So now if I'm able to put that power into somebody else's hand and let them be the initiator, I can now be the initial reviewer. And then somebody else who works alongside of me can now be their reviewer. So when I go ahead and I look at, let's see here. I look at a particular change. What I have here is you're going to see that one of the best practices, and a lot of things have happened with GitHub and Gitlab over the past 5 years where people have quote unquote accidentally uploaded their AWS secret and keys. Not saying anybody in this room's done it. So then all of a sudden, next thing you know, you've got about 5,000 VMs doing Bitcoin mining on your behalf, and you get a bill for $5,000 at the end of the month. So what we want to be able to do whenever we're doing GitOps is we want to figure out a way to variabilize as much of this workload as possible. And when we talk about variabilizing these things, this is like your secret and key. I can take these things and use my platform to be able to store those keys in a vault, and then I can pull those whenever I need to run it. So now I've got a location where my secrets are able to be managed. So for other people, I think it's ISO 9001 standard says that your keys need to rotate every 30 to 60 days. Well, now you can have a process that you can make sure that your variables change every 30, 60, 90 days. And when I go ahead, my code never changes, but the actual credentials that are being stored inside the system are being updated on the fly. There's even some things where you might want to integrate this with something else like HashiCorp Vault, and it will generate a brand new secret and key every time this gets run. So you get something brand new every time. Now, as we think about using these variables can then be reused. So anybody here who has ever provisioned a VM inside of AWS, we've got to have network connectivity. We have to have ingress points. We've got to tell it what size image it's going to be, all of those things. Well, one of the things that I've heard from a lot of operations people is that when they think of it, they look at how they need to, they look at how developers' workstations are set up. And they go, Lee, look, I don't want to have to install VS Code on my laptop. I don't want to have to install the Terraform plugin and the Kubernetes plugin and the YAML plugin. And then I've got to worry about how do I do Git locally on my machine. And I don't know all the different Git commands. I mean, geez, I used to do Subversion. When I used to do a commit, it talked directly to the server. I don't want to learn all this new technology. Well, all these tools today that we have, I don't need to worry about that. If I am in operations, all I need to do is, in all of the different tools support this today, is I can just go click and I can open up the web IDE. And now when I open up the web IDE, I can make changes here inside of my files. And as soon as I make a change to a file, and let's see what I can do here. You'll notice over here down at the bottom left-hand corner, notice you've already made a change. So all I have to do is I can go ahead and I can commit this. And now when you commit this, you'll notice that by default, it's telling me, do not commit to main. Please don't commit to main. So what I can do is I can say, oh, I'm going to go ahead and commit this. And there's a really interesting trick that when you go ahead, you can use a slash. And now what I've done is, as developers best practice says that when you create a branch, I'm going to create it as a feature branch, a hotfix branch, a bug branch. Those are sort of my naming conventions because my CI is going to pick up on those naming conventions. Well, then we obviously should have one for our infrastructure team. So why not have an infrastructure branch? So now if my infrastructure is going to live with the source code for my application, I can have an infrastructure branch, and then I can sit there and say, change default key. And then I'm gonna commit this. And now you'll see it immediately takes me into what's called a merge request. Now, again, I'm aging myself. Continuous integration has a completely different meaning to me than it probably does to a lot of you. A lot of you think about continuous integration, you go, oh, that's Jenkins. No, continuous integration to me goes back to way back in the early 2000s when we used to build wars and ears for JBoss and for WebSphere, and we were using tools like CVS and ClearCase and SVN. And what you needed to do is it was really hard for you to merge this code together. So what you wanted to do is you wanted to check the code before it ever got into the mainline repository, because once it gets into the mainline repository, what does it become? It becomes auditable. So if somebody puts something really bad into main or into master inside of your branch, it is in there forever. It is part of history. Just like getting your name as an executive in the Wall Street Journal because you exposed everybody's social security number inside your company. Those are things that you don't always want. So now when you have your merge request, I can say draft, saying, hey, I want somebody to come along and help me out. Need to change default key. And then as we talk about a description, this is all markdown. So now we want to have a little bit of a conversation with the other people inside of our team. I might want to bring in a developer. So I've actually got somebody here on my team. So this is my alternate persona, continuously. So can you please review this? Now, a lot of times you're going to have what we call an MR template. So you would probably want to have one for infrastructure. So there's probably going to be a checklist of things that need to happen anytime you make a change. So you could have that template that automatically pops up because, hey, I'm in my infrastructure branch, so might as well use the infrastructure template. And then I can go through and say, okay, here's all the different checkboxes I need to have before I can go ahead and merge them. And once we go ahead and do this, I can have assignees, I can have reviewers, all of those things take place when I go ahead and create a merge request. Now, once we go ahead and we have this, we've got our merge request, and what we're going to do is we're going to see if it can actually be merged. What is happening in the background is we're going to see that I've automatically started running a CI job. Now, inside of my CI job, what I'm going to do is, because I've got Terraform code, I want to make sure that my Terraform code is all formatted the same. So I can run a linter in the background. I can also automatically start running the Terraform command line. So if I go in and look, and because this is a live demo, it's probably always going to fail. So what I'm going to do is I'm actually going to run, Terraform actually runs in 4 different phases. One is init, one we've got validation, so I want to make sure everything's formatted properly. I can then plan, which is actually an apply, and then I can actually destroy it. So when I go through this entire process, I can actually see these things run in real time. I have not actually created any infrastructure yet. What I'm doing is, just like when I'm a programmer, I'm running a series of unit tests. I've got to go ahead and make sure that what I'm about to perform is actually okay for me to perform. Now, because of the way that this is running, there's a really cool company. If you have not talked to them, they are outside to the left. If this is of any interest to you and you're really concerned about security, you need to go talk to the folks over at the Styra booth. One of the things that I am running right now is, inside of this test, is I'm running one of the things from them called conf test. So what I was able to do is, my conf test here is, you can see I've got 1 test and I've got 1 passed. What happened is, inside of my repository, I've got a policy, and what Styra supports is a CNCF project called OPA, which is the Open Policy Agent. So what OPA has done is, this is going to get run from conf test. And what it's going to do is, it's going to check to see if one of the rules that I've got is, if I've tried to open up SSH on that EC2 image. If I've tried to open up SSH on that EC2 image, that particular item would have failed. So let me try really quick. Let me back. I'm going to try to remember what that name is. So I'm going to try to open up SSH TCP, which now, if I put this on my infrastructure, it's not. Hold on, I did that the wrong way. I got to change my branch first. Okay, so now I'm going to go in and try changing that. So now if we go back, and it should tell me down here, it should kick off a new pipeline. So what we should see here is underneath this test will now fail. So because everything is code, I can check that code for best practices. I'm creating guardrails for people to enable them to do self-service. I'm also giving a way for us to not shoot ourselves in the foot because we've already got built-in best practices into the way that we're actually going to release this infrastructure. So when we think about how this actually works, I want to see this actually fail. This is a really powerful concept that there's other tools that exist inside the space. So there's tools for Ansible, there's tools for Puppet. All of these different projects all have different ways for you to be able to validate and make sure that you're following best practices. So here, what we have is we have a fail. So now I can see, you can imagine as a developer, if a developer is trying to use this script and they've made modifications and they come in and all of a sudden their CI job fails, I've now provided them feedback. And I could give them a list. What conf test does is I just have one thing in there. You could have 30 things in there that you're checking, all inside that one file. And what would happen is conf test would actually come back and show me all of the things that are failing. A lot of times whenever we're working with security, what we'll do is we only get one at a time. You get one thing failed, and then I go and fix it. And then another thing fails, and I need to go back and fix it. And another thing fails, I gotta go back and fix it. This will give me the list of everything that fails. I can go fix it all in one shot, and then I can come back and go ahead and have the CI job rerun inside that branch. Once I see a lot of these tools, so GitHub, Bitbucket, Gitlab, they all have these things called branch protections. So because this CI job has failed, my status for this merge request is currently in a failed state. So I can make it that I can't merge this in. So I have to wait for all of my checks to come across as valid before I can ever even try to merge that into another branch. And I can have reviewers to make sure that I've got people checking, not only did I do an automated test, but I can also do a manual test as well. So what does this look like from a CI perspective? So, and this is all, if you guys go to, this is all public on gitlab.com. There's a project called Honeydew, and then it's under all things open. There's a grouping and subgrouping concept inside of GitLab. And you can go in there and you can see this entire repository. So if you wanted to go through and you wanted to fork this and you wanted to play around with it, what you'd have to do is create your own secrets. So you'd have to put your secrets in at the project level. You can read the docs. It's really easy to add them in. They all map, and I'll show you how they map in here in a second. Okay. So what we've done here is we've got our Terraform state and where we're going to store everything. And then we also have the root. So the root is just the base of the repository. If you were storing your Terraform code with your actual source code for your application, you can change that root. So you might have a Terraform directory or an infrastructure directory, and then it would always build from that particular location. As we go down and look at some of the different variables that get run, what we've done here is we've created some workflow. So the workflow rules that I've defined is I say, oh, if I'm inside of a merge request, then I need to make sure that these particular Terraform actions run. If I'm merging into main, I don't need to rerun them because I've already been run once. It's one of the things that frustrates me with COVID. I've got to go ahead and get tested to get onto the plane to fly to a foreign country. But as soon as I get off the plane, I have to get tested to make sure that I didn't get COVID on the plane ride over. So it's just crazy. Like once I go ahead and I merge, I should be good because I've already tested it beforehand. It should automatically be verified on the when I merge it. And then as we go through for different variables, I can then change my tags, which end up getting passed in. So a lot of times when we think about our cloud infrastructure, we've got usually a dev set of tags and we've got a production set of tags. This allows us to maintain that consistency across everything. And then we've got our different stages that we're going to run across all of those. So the last thing that I want to leave you with is when you think about GitOps, GitOps is part developer experience. So it's that merge request, pull request, having your protections in place, having a place to store that code transparently, allowing other people to collaborate with you, allowing you to learn best practices. At the same time, it's the automation that exists on the back end. How do I use other third-party open source frameworks that I can go ahead and validate that source code that I've got in that repository to make sure that I'm not shooting myself in the foot, making sure that what I've written is good quality code. Okay. All right, thank you very much.